In your pharmaceutical analysis, you have two parts rather than you have three parts. First part is nothing but the volumetric analysis. In that, various kind of titrations are there. So, like acid-base titration, then complex metric titration, non-aqueous titration, iodimetry, then oxidation reduction titrations. So, all these titrations and they are known as a volumetric analysis. So, there you measure a volume. Okay, there you measure a volume for either qualitative purpose or quantitative purpose. So that is a volumetric analysis. Another part of your analysis is nothing but the instrumental analysis. So where different kind of instruments are there to measure a different property. And third part is nothing but the chromatographic analysis. So there you will have different kind of chromatographic techniques like your column chromatography, then after that paper chromatography, HPLC, HPTLC, thin layer chromatography, size exclusion chromatography. There are different types of chromatography. We will see in upcoming sessions. So today we'll see visible spectroscopy and UV spectroscopy if I can finish today. What do you mean by spectroscopy? So the term spectroscopy is made up of two words. This term is made up of two words, spectroscopy. Okay? So first word is a spectro. Spectrum is spectrum and scopy means measurement. Okay, what is a spectrum? Spectrum is a electromagnetic spectrum, EMR, electromagnetic radiations, a spectrum or a band of electromagnetic radiations. What do you mean by electromagnetic radiations? Whatever light you are able to see by your eyes, whatever light is there from sun, so that is a having particular band, that is having particular wavelength, so known as a visible light. So ये आपको दिख सकता है इसलिए उसको visible बोलते हैं. ओके, अल्ट्रा वायलेट मीन्स लेस देन विजिबल, विजिबल से नीचे जिसका वेवलेंथ रहेगा उसको बोलेंगे अल्ट्रा वायलेट. ओके, so there is a spectrum of electromagnetic radiations. So there you will have different kind of electromagnetic radiations. वहाँ पे डिफरेंट काइंड के रेडिएशंस रहेंगे, जैसे यूवी रहेगा, आईआर रहेगा, अल्ट्रावायलेट रेज, देन इंफ्रारेड रेज, देन माइक्रोवेव रेज, रेडियो फ्रीक्वेंसी वेव्स, एक्स रेज, gamma rays, UV rays. Okay, then these kind of different kind of rays or radiations, you can say radiations. So these radiations they are a part of electromagnetic radiations. Electromagnetic radiations they are known as a particular spectrum, electromagnetic spectrum. Electromagnetic spectrum or electromagnetic radiations, it is a common term for all kind of radiations. So it is a common term for all kind of radiation. So in that you will have a different kind of radiations. Okay, so radiations having different wavelength, different energy. So examples, for example, microwave region will be there, then UV region will be there. There you will have UV radiations. In the microwave you will have microwave radiations. In the X-ray you will have X-ray radiations. In the gamma region you will have gamma. In the radio frequency region you will have radio frequency waves, okay, or rays. In infrared you will have infrared radiations. So like that, in the visible region you will have visible radiations. Okay, so visible region normally in the spectrum it lies between 400 to 800 nanometer. तो आठ ओके 4 से ते 800 नॅनोमीटरला आपण काय म्हणतो विजिबल रेंज. तर 2 से ते 400 जे असो, सो द region of electromagnetic spectrum from 200 to 400 nanometer is known as the ultraviolet region. 400 to 800 nanometer is known as a visible region. Okay, like that. Okay, below the UV 190 there is a vacuum UV region. After before that this there is a before that there is a microwave region. Before that there is a again there is a radio frequency region. Okay, so spectroscopy. So what do you mean by spectroscopy? So spectroscopy deal with the measurement and interpretation of the effect of electromagnetic radiations that is being absorbed or emitted by molecule. So you have some kind of compound, organic compound or inorganic compound or any compound. So that compound, when a particular kind of radiations or waves that is passed on that compound, so there are different chances. So that with few of radiations, the compound may absorb few of radiation. That compound may deflect that radiation. That compound may transmit that radiation. So there are different possibility कि अगर कोई कंपाउंड है आपके पास में, उसमें उसके ऊपर आपने रेडिएशन डाल दिया. रेडिएशन मतलब एक कॉमन टर्म होगा, इट इज नॉट अ पर्टिकुलर टर्म. पर्टिकुलर मतलब यूवी अगर आ गए तो 200 200 to 400. तो रेडिएशन अगर कोई भी कंपाउंड के ऊपर डाला एंड इफ दैट कंपाउंड, उसके ऊपर क्या इफेक्ट होगा उसका, रेडिएशन मतलब क्या है उसमें, रेडिएशन इज नथिंग बट ए वेवलेंथ, पर्टिकुलर रे ऑफ पर्टिकुलर वेवलेंथ. And what is what is wavelength? Okay, so what is wave? It will wavelength will have characteristic of two part. It will have characteristic of your electric part and as well as, so if you uh, if you pass a particular radiations from a compound, so there are different possibility that compound may absorb that radiation, the compound may transmit that radiation, or that compound will partially absorb some radiation and will transmit another radiations, or that compound will reflect that radiation, will send it back, or that compound will reflect that radiation, or that compound will scattering of radiation. मतलब वहाँ पे डिफरेंट डिफरेंट पॉसिबिलिटी होता है कि एक कंपाउंड के ऊपर आपने रेडिएशन रेडिएशन पास किया, वो रेडिएशन कंपाउंड डिपेंडिंग ऑन द नेचर ऑफ कंपाउंड, दैट रेडिएशन कुछ पार्टली एब्सॉर्ब भी हो सकता है, या फिर पूरा एब्सॉर्ब हो सकता है, या फिर पार्टली एब्सॉर्ब हो सकता है, या फिर पूरा एब्सॉर्ब हो ही नहीं सकता, ट्रांसमिट हो जाएगा पूरा, या फिर उसमें का रिफ्लेक्ट भी हो सकता है, उसमें का डिफ्रैक्ट भी हो सकता है, और वो स्कैटर भी कर सकते हैं. सो देयर आर डिफरेंट पॉसिबिलिटी. नाउ स्पेक्ट्रोस्कोपी इज नथिंग बट इट डील्स विद द मेजरमेंट एंड interpretation of effect of electromagnetic radiation absorbed or emitted when a molecule or atoms or ions of the sample moves from ground state to excited state and vice versa. भी इसका मतलब क्या है कि if a particular radiation मतलब क्या है, it is kind of light. Radiation मतलब it is a kind of light. अभी light क्या है, kind of light, ठीक है, light will have energy, light को क्या है, energy आता है. सो पर्टिकुलर वेवलेंथ का लाइट कौन सा भी, मतलब यूवी रीजन का अगर वेवलेंथ का लाइट है, उसको भी एक पर्टिकुलर काइंड का एनर्जी रहेगा. आईआर रीजन में जो लाइट आता है उसका जो वेवलेंथ है उसमें भी पर्टिकुलर टाइप का एनर्जी आएगा. विजिबल जो लाइट है उसका भी एक एनर्जी होता है, रेडियो फ्रीक्वेंसी लाइट है उसका भी एक एनर्जी होता है. तो हर एक रेडिएशन जो है पर्टिकुलर टाइप ऑफ रेडिएशन विल हैव पर्टिकुलर टाइप ऑफ एनर्जी एंड विल, okay, and that energy will be absorbed or emitted or transmitted by the molecules on which that radiation has been fallen. Now molecule compound मतलब क्या, compound में क्या रहेगा, compound में रहेंगे molecules और atoms रहेंगे या फिर ions रहेंगे. So when a, okay, so spectroscopy deals with the measurement and interpretation of effect of electromagnetic radiation absorbed or emitted, okay, emitted when a molecule, okay, emitted when a molecule or atom or ions of the sample move from ground state to excited state. इसका मैं इसका मीनिंग जो है ग्राउंड स्टेट एक्साइटेड स्टेट, आई विल एक्सप्लेन दिस इन अपकमिंग स्लाइड्स. ग्राउंड स्टेट मतलब, a ground state means a state of your sample, that is the resting state. At that stage or at that state your molecule will have least energy. So if your molecule have least energy and it is in the phase of rest, that is known as the ground state. Now if a particular radiation is absorbed by that sample, so radiation means it is nothing but the having energy. That energy is absorbed by that molecules of your compound. Now that molecule where they were present in the ground state, after absorption of energy they will move to the excited state. Now okay, now ground state में जो उसके characteristics थे, so whatever characteristics was there in a ground state of your compound may differ with the characteristic now present in the excited state. तो जो ग्राउंड स्टेट में होता है तो उसका जो पर्टिकुलर कैरेक्टरिस्टिक होता है वो चेंज होता है एक्साइटेड स्टेट में जाने के बाद में. जैसे मान लीजिए कि एक एग्जांपल पोलैरिटी, so there is a change in the polarity of compound when it is excited. So when it is on a ground state, it will have a different kind of polarity, and when it will absorb the radiation and it will excited, at that time it will have a different kind of polarity. So that property is measured in the spectroscopy. What is the meaning of spectroscopy? So it deals with the measurement and interpretation of effect of electromagnetic radiation एब्सॉर्ब्ड और इमिटेड. एब्सॉर्ब मतलब उसने खा लिया, इमिटेड मतलब छोड़ दिया, ठीक है. सो एब्सॉर्ब और इमिटेड व्हेन अ मॉलिक्यूल और एटम और आयंस ऑफ द सैंपल विल मूव फ्रॉम ग्राउंड स्टेट टू एनर्जी स्टेट और वाइस वर्सा. सो वाइस वर्सा मतलब जो एक्साइटेड मॉलिक्यूल है that will release the energy. When an excited molecule is there, so that molecule will release the energy and will try to come at a ground state by releasing energy. There is known as a relaxation process. Okay, I will explain this also again in, so just you have to understand what is spectroscopy. Now ground state means what? Ground state consists of a ground state means at a relaxed state. Oh, okay. At that state also your compound will have a different kind of energies. Okay, like ground state will have a total sum of rotational, vibrational and electronic energies. Ground state will also have these three energies. तो ये ground state में ये energy होता है molecule को. Okay, your molecule at a ground state or at a relax will have energy, some energy. So that energy is nothing but the composed of a rotational energy, vibrational energy and electronic energy. So a combination or a addition product of these three energy, that is nothing but the total energy of your compound. Now after falling any particular radiation on this compound, so it get excited from ground state to excited state. Means what will happen? So by by absorbing the radiation, your compound's energy will be changed. Now what kind of energy? By absorbing the light or by absorbing the radiation, your compound may change its rotational energy or may change its vibrational energy or may change its electronic energy, may change its electron. So there will be changes in these energy levels of your compound after absorption of particular radiation from the electromagnetic spectrum. So your compound or your sample will have change in the energy state, change in the energy state. ये energy state में change हो जाएगा उसकी. And that is measured in the spectroscopy. So if that particular radiations having particular wavelength, अभी वो radiation अगर UV range का है तो उसको बोलेंगे UV spectroscopy. अगर वो radiation अगर infrared region का है तो उसको बोलेंगे infrared spectroscopy. अगर वही radiation अगर आपका X-ray region का है तो उसको बोलेंगे X-ray स्पेक्ट्रोस्कोपी. अगर वही रेडिएशन अगर आपका माइक्रोवेव रीजन का है तो उसको बोलेंगे माइक्रोवेव स्पेक्ट्रोस्कोपी. तो लाइक दैट उसमें भी बहुत सारा टाइप आता है, इमिशन है, एब्सॉर्प्शन है. तो विल सी इट इन अपकमिंग स्लाइड्स. नाउ व्हाट इज ईएमआर? ईएमआर मींस इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम. इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम मतलब आप इतना याद रखो, इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम मतलब इट इज अ काइंड ऑफ वेव्स. ओके, इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम मींस लाइट. लाइट मतलब अपन लाइट किसको बोलते हैं कि जो विजिबल है उसको बोलते हैं. पर विजिबल के नीचे भी कुछ इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम होते हैं जो विजिबल नहीं है लेकिन उसमें एनर्जी होता है. ओके, सो इलेक्ट्रोमैग्नेटिक रेडिएशंस दे आर कंप्राइज ऑफ डिस्क्रीट पार्टिकल्स. इलेक्ट्रोमैग्नेटिक जो इलेक्ट्रोमैग्नेटिक रेज जो होते हैं, रेडिएशंस जो होते हैं, उसमें क्या होता है कि पार्टिकल्स होते हैं उसमें. दे आर मेड अप डिस्क्रीट मतलब अलग अलग पार्टिकल्स. दे आर मेड अप डिस्क्रीट पार्टिकल्स. दे आर नोन एज फोटॉन्स. सो इलेक्ट्रोमैग्नेटिक रेडिएशंस दे आर कंपोज्ड ऑफ डिफरेंट discrete particles known as a photons. So जो भी radiations होते हैं their radiation is measured in the radiation का जो basic unit होता है उसको बोलते हैं अपन photon. Okay, so EMR और electromagnetic radiations comprises the discrete particles known as a photons. ठीक है, EMR has a both characteristic. कौन से? wave characteristic as well as particle characteristic. ठीक है, wave characteristic as well as particle characteristic. So electromagnetic spectrum will have two characteristic. फर्स्ट वन इज अ वेव. ये व्यू हो गया, व्यू नहीं वेव, WAV. वेव कैरेक्टरिस्टिक एज वेल एज पार्टिकल कैरेक्टरिस्टिक. दैट मींस ए इलेक्ट्रोमैग्नेटिक रेडिएशन, नॉट अ पर्टिकुलर, इस इलेक्ट्रोमैग्नेटिक रेडिएशन कैन ट्रैवल इन द वैक्यूम आल्सो. ये वैक्यूम में भी ट्रैवल कर सकता है एंड मैटर से भी ट्रैवल कर सकता है. So electromagnetic radiations can travel in the vacuum as well as in the matter. Okay, so it will have both characteristic of wave as well as characteristic of particles. Now particle characteristic of this EMR electromagnetic radiation can be called as a photon. तो उसमें जो उसका पार्टिकल है उसको बोलेंगे फोटॉन. ओके, नाउ टाइप्स ऑफ इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम कितने टाइप के होते हैं? देयर आर डिफरेंट टाइप्स ऑफ इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम हैविंग डिफरेंट वेवलेंथ और डिफरेंट फ्रीक्वेंसी और एनर्जी. ठीक है, सो इलेक्ट्रोमैग्नेटिक रेडिएशन में डिफरेंट टाइप्स के वेवलेंथ रहेंगे, उसके उसके अकॉर्डिंगली उसको नाम दिया है. सो इफ पर्टिकुलर वेवलेंथ इज देयर तो उसको ये बोलेंगे, उसको ये बोलेंगे, उसको. ओके, सो इलेक्ट्रोमैग्नेटिक रेडिएशंस विल हैव डिफरेंट radiations falling under different wavelength, different frequency and they will have different energy. ठीक है, तो जैसे एक्सरे का एनर्जी अलग रहेगा, यूवी रेज का एनर्जी अलग रहेगा, माइक्रोवेव का अलग रहेगा. ओके, रेडियो फ्रीक्वेंसी अलग रहेगा, आपका इंफ्रारेड रेडिएशन का एनर्जी अलग रहेगा. सो एवरी रेडिएशंस विल हैव डिफरेंट एनर्जी. some of them will have higher energy, some of them will have lower energy. So types of electromagnetic radiation having different wavelength or frequency or energy. Okay, types of radiations are nothing but the UV radiations, then IR radiation, then microwave radiation, radio waves, X-ray, gamma rays और cosmic rays. ठीक है. So इतने सारे टाइप के radiations रहेंगे आपके. There are different kind of radiations in the electromagnetic spectrum, like UV radiations are there, IR radiations are there, radio waves, cosmic rays, okay, microwave rays, etc., etc. Okay. So electromagnetic radiations, they are composed of a different kind of wavelengths or different frequencies or energy. So they will have different radiations, will have different energy, different radiation will have different frequency and different wavelength. Okay, so UV will have a 200 to 400 nanometer wavelength. Okay, then visible region will have 400 to 800 nanometer. Okay, like IR will have a 2.5 to 15 micron range. So each and every will have a different wavelength, different frequency, different energy. Now energy of electromagnetic radiation is given by one formula. Energy of electromagnetic radiations is given by one formula. क्या है formula? E is equal to hv. So energy of electromagnetic radiation, that is given by one formula. E is equal to hv. So ये E क्या है? E means energy. So what is E? E means energy. H means what? H is nothing but the Planck constant and V is nothing but the wavelength. Okay. So energy of electromagnetic radiation, particular radiation, will have E is equal to hv. Okay, what is the energy of radiation? H is nothing but known as a Planck constant और इसका वैल्यू होता है 6.2. okay, 6.624 into 10 to minus 34 जूल सेकंड. ये आपको याद रखना है, इसका ऊपर क्वेश्चन आ सकता है. okay, so what is the Planck constant? ये माइट आपको 12th में भी हुआ होगा. Planck E is the energy, H is the Planck constant, that is 6.624 into 10 to minus 34 joule second. okay, then V is nothing but the frequency of radiation. What is V? V is nothing but the frequency of radiation, and it is given by what is frequency? Frequency is nothing but the frequency V is equal to, okay, frequency is V is equal to C upon lambda. What is C? C is nothing but the velocity of light. C is nothing but the velocity of light, और इसको speed of light भी बोलेंगे हम. What is lambda? Lambda is nothing but the wavelength. So it is calculated as like this: 3 into 10 raised to 8 meter second per second inverse divided by wavelength. So you can calculate the energy of wavelength. आपको अगर पूछा है कि what is the energy of 300 nanometer, so आपको कैलकुलेट करते आना चाहिए 3 into 10 raised to 8 meter per second inverse divided by 300 nanometer. Energy is equal to hv is equal to hc lambda divided by lambda is equal to hv को आप ऐसे भी लिख सकते हैं, hv को hc divided by lambda. c क्या है? velocity of light. h is Planck constant into c velocity of light divided by lambda, that will give you energy of, or other words you can say in case of wave number, अगर wave number mention किया है तो आपको ऐसे भी calculate कर सकते हो. h c v is nothing but the wave number. And what is what is wave number? It is the reciprocal of your wavelength. Where v is nothing but the wave number. It is mentioned in the form of centimeter inverse. ये wave number जो है वो centimeter inverse में ही denote किया जाता है. And wave number is used in the IR spectroscopy. In case of infrared spectroscopy, wave number is denoted. In case of your other spectroscopy like UV, then NMR and all that. So wavelength is denoted. So what is wavelength? That is also we are going to see what is wave number. That is we are also going to see what is the unit of wavelength. We are going to see. We don't worry about that. Now energy of radiation depends on the frequency and wavelength of radiation as per the above equation. Right. Now what is frequency? Frequency is nothing but the number of complete wavelength units passing through a given point in a unit time. What is wavelength? What is frequency? Number of number of wavelength units passing through a given point in a unit time. उसको बोलेंगे wavelength. कि एक unit time में एक point से कितने wavelengths जा रहे हैं, तो उसको बोलेंगे frequency. Okay. Now unit of frequency is nothing but the frequency. Frequency is always denoted by either hertz, hz, hertz, or cycles per, okay, cycle per second, okay, hertz or cycle per second. ये units है. Okay. These are known as a slower or lower unit of the frequency. Hertz and cycle per second, they are known as a lower units of frequency. Okay. There are higher units of frequency also. Higher units क्या है? Like kilohertz, megahertz, then parcel. Okay, these are the higher units of frequency. Kilohertz, 1 kilohertz is equal to 10 raised to 3 hertz. Okay, 1 megahertz, okay, 1 mh 1 megahertz is equal to 10 raised to minus 6 hertz, and 1 parcel is equal to 10 raised to minus 12, like this. So number of complete wavelength unit passing through a given point in a unit time, that is known as a frequency. Now next one is a wavelength. Okay, we have seen what is frequency. Okay, what is frequency? It is nothing but the number of wavelength units passing through a particular point in a unit time. Now what is wavelength? Okay, wavelength is nothing but the distance between two successive maxima or minima, or that is nothing but the distance between two successive troughs and crest. So मान लीजिए आपका ये इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम है, मतलब ये नॉट अ इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम, इट इज अ जस्ट वेवलेंथ. ओके, वेव है, पर्टिकुलर रे है, पर्टिकुलर वेवलेंथ का लाइट है. ओके, so in that you will have light travels in the vacuum in zigzag manner. Okay, like this. So this part is known as a crest and this part is known as a tuft. So distance between two successive maxima or two successive minima. So distance between either two successive maxima or two successive minima, or distance between two successive crest or two successive tuft, known as a wavelength. Okay, known as a wavelength. Now we can measure the wavelength in different units. Like you can measure wavelength in the meter or centimeter, that is 10 raised to minus 2 meter. Centimeter means 10 raised to minus 2 meter. Then millimeter means 10 raised to minus 3 meter. ठीक है, मीटर में क्या होता है, जैसे मीटर में होता है 1000 सेंटीमीटर. देन मिलीमीटर में क्या होता है, सॉरी मीटर में होता है 100 सेंटीमीटर. मिलीमीटर में क्या होता है, ठीक है, मिलीमीटर में होता है 1000 मिलीमीटर इज इक्वल टू 1 मीटर. ओके, 100 सेंटीमीटर इज इक्वल टू 1 मीटर. 1000 मिलीमीटर इज इक्वल टू 1 मीटर, लाइक 10 raised to minus 3. Micrometer minus 6. Okay, 1 micrometer is equal to 10 raised to minus 6. Then nanometer means 1 nanometer is equal to 10 raised to minus 9 meter. And or angstrom means 10 raised to minus 10 meter. क्वेश्चन इसके ऊपर भी आता है आपको, 1 angstrom is equal to how much meter, or 1 nanometer is equal to how much meter. Okay, so remember, centimeter 10 raised to 2, millimeter 10 raised to 3. Okay, centimeter 10 raised to minus 2, millimeter 10 raised to minus 3, micrometer 10 raised to minus 6, nanometer 10 raised to minus 9. Nano for 9, you can remember, nano for 9. Okay, then angstrom for 10. So 1 angstrom unit is equal to 10 raised to minus 9 meter. That is a wavelength. Now wave number is what? Number of waves per centimeter. एक सेंटीमीटर में कितने वेव्स है, नंबर ऑफ वेव्स पर सेंटीमीटर is nothing but the wave number. Okay, क्वेश्चन इसके ऊपर आ चुके. What is wave number? Number of waves per centimeter. तो ऐसा नहीं आएगा. Now wave number is nothing but the reciprocal of your wavelength. Remember, wave number is a reciprocal of your wavelength. If you denote wavelength by lambda, तो wavelength जो है आपका, वो आपका wavelength जो है वो अगर lambda से डिनोट करेंगे आप, lambda से, ठीक है. So 1 upon lambda, क्या 1 upon lambda is nothing but the wave number. 1 upon lambda is nothing but the wave number. Okay, wave number is nothing but the reciprocal of your wavelength. Wave number क्या है? Reciprocal of your wavelength. Number of waves per centimeter, that is the reciprocal of your wavelength, and it is denoted in the centimeter inverse or Kaiser. These are the two units. Centimeter inverse and Kaiser are the units of wave number. Okay, normally wave number is used in the IR स्पेक्ट्रोस्कोपी. तो IR स्पेक्ट्रोस्कोपी में जो इंफ्रारेड रेडिएशंस होते हैं, वेवलेंथ की बजाय वेव नंबर यूज करते हैं, वेवलेंथ की बजाय वहां पे वेव नंबर यूज करते हैं. So most commonly used in the IR spectroscopy. It is a frequency, wavelength and wave number. These are the basic terms you have to understand. Okay, what is frequency? Number of complete units wavelength passing through a point in a given unit time, that is a frequency. What is wavelength? Distance between two successive maxima or minima or crest or top, that is nothing but the wavelength. Wavelength is measured in the meters. Okay, frequency is measured in the hertz or cycle per second. तो cycle per second छोड़ो, hertz से याद रखो, hertz. Okay, so 1 kilo hertz is the lower unit, cycle per second is the lower unit of frequency. Higher units like 1 kilohertz, that is equal to 10 raised to 3 hertz. 1 megahertz is equal to 10 to 1 parcel is equal to 10 raised to 12 hertz. Okay, then wavelength may be measured in the meter, okay? Centimeter or millimeter or micrometer or नैनोमीटर और एंगस्ट्रॉम। तो वेवलेंथ का डिफरेंट डिफरेंट यूनिट्स है। तो मीटर 1 सेंटीमीटर इज इक्वल टू 10⁻² मीटर, 1 millimeter is equal to 10⁻³ micrometer means 10⁻6 meter, nanometer means 10⁻9 meter, and 1 angstrom means 10⁻10 meter. Wave number क्या है? It is nothing but the waves per centimeter, number of waves per centimeter, or reciprocal of your wavelength. Okay, it is denoted by centimeter inverse or Kaiser. And it is most commonly used in the spectroscopy, that is IR spectroscopy. Now frequency, again we have seen this equation. So again you can see frequency is nothing but the speed of or velocity of light divided by wavelength. Okay, so you can calculate the, or energy of radiation, you can calculate also energy also. Now electromagnetic spectrum, as you can see in this image. Okay, so electromagnetic spectrum, these are the electromagnetic spectrum. So electromagnetic spectrum we have different kind of waves, different kind of waves with different wavelength, different energy. Okay, different wavelength and different energy, different wave number. Okay, so in the electromagnetic spectrum you will have different radiations like gamma rays. Gamma rays, they will fall, their wavelength is nothing but the 10⁻12 मीटर. ठीक है, 10⁻12 मीटर में के रेंज में अगर कोई वेवलेंथ है तो उसको गामा रेज बोलेंगे. इफ 10⁻10 के मीटर में कोई वेवलेंथ है तो उसको बोलेंगे एक्स रेज. 10⁻8 मीटर की वेवलेंथ का रेंज जो है उसको बोलेंगे अल्ट्रा वायलेट रेज. तो विजिबल रेंज क्या होता है? 0.5 टू 0.5 इंटू 10⁻6 मीटर. इंफ्रारेड रीजन क्या है? 10⁻5 मीटर. उसके बाद में आता है माइक्रोवेव 10⁻2. लास्ट में आता है आपका रेडियो 10⁻3. Radio waves can pass through buildings. Okay? Microwaves can pass through your humans and butterflies. Okay? Infrared waves can pass through a minute opening like needle. Okay? Then visible light can pass through a bacteria also. Ultraviolet rays, whatever energy is there, they can change the electronic parameter of your molecule. X-ray will have this energy. X-ray is not X-ray they are not penetrate. X-ray, they are reflected through metals. Okay. Then gamma rays. Gamma rays, they will only excite atoms of molecule. Okay, atoms of molecule. So they will have different frequency like radio frequency 10⁻4. Okay. So microwave 10⁻8 hertz. Okay. So ये था आपका वेवलेंथ है. इसमें क्या है? वेवलेंथ 10⁻3 मीटर. ओके, अप्रोक्सीमेट वेवलेंथ. ये फ्रीक्वेंसी क्या रहेगा उसका? 10. ओके, रेडियो फ्रीक्वेंसी क्या है? 10⁻4 हर्ट्ज, 10⁻8 हर्ट्ज इसका रहेगा माइक्रोवेव रीजन का. ठीक है, इंफ्रारेड का कितना रहेगा? 10⁻12 हर्ट्ज. ओके, उसके बाद में इंफ्रारेड एंड यूवी का रहेगा. ये इंफ्रारेड के बाद में यूवी आता है, उसके बाद में आता है आपका विजिबल, उसके बाद में यूवी का कितना रहेगा? 10⁻15. ओके, देन अल्ट्रावायलेट 10⁻16 10⁻16 हर्ट्ज, 10⁻18 हर्ट्ज रहेगा आपका एक्सरे का, 10⁻20 हर्ट्ज रहेगा गामा रेज का. ओके, तो रेडियो वेव्स विल नॉट हैव एनर्जी. रेडियो वेव्स में एनर्जी होता ही नहीं ज्यादा, उसमें हीट नहीं होता. ओके, उसमें हीट ज्यादा होता नहीं है. माइक्रोवेव में एनर्जी होता है 1 केल्विन तक. इंफ्रारेड में एनर्जी होता है 100 केल्विन तक. ठीक है, विजिबल में 10,000 केल्विन तक एनर्जी होता है. जैसे आपका सनलाइट, एक्सरे वगैरह ये है, उसमें बहुत ज्यादा एनर्जी होता है. एक्सरे गामा रेज उसमें 10 ओके 10 लाख डिग्री सेल्सियस का टेम्परेचर रहेगा उसका. तो इट इज इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम. की स्पेक्ट्रम में बहुत सारे ये है क्या, डिफरेंट टाइप ऑफ रीजन्स है, डिफरेंट टाइप ऑफ रेज है, लाइक रेडियो वेव्स, माइक्रोवेव्स, इंफ्रारेड radiations, visible radiations, ultraviolet radiation, X-ray region, gamma rays. Okay, these regions will have different wavelength. These regions will have different wave number. These regions will have different energy. So each and every single spectroscopy deals with the single spectrum. Like UV spectroscopy deals with the only radiations that falls in the UV region 200 to 400. Visible spectrum deals with the only 800 to 400 to 800 नैनोमीटर. तो 400 200 से 400 200 to 400 नैनोमीटर का रेंज जो है, that is the range for ultraviolet radiations. So in the UV spectroscopy we use that radiations only. So in the visible, what is the range? 400 to 800 nanometer. So in the visible we use only that radiations. Okay, So particular spectroscopy deals with a particular type of radiation. Like for example, in a NMR spectroscopy, you use radio frequency beams. You use radio frequency beams. In case of infrared spectroscopy, you use infrared radiation. So particular spectroscopy deal with the particular type of radiation. Okay. Now whatever light or radiation coming, that radiation is nothing but the having different wavelength radiations. ठीक है, ये जो बीम आता है आपका लाइट का बीम. Okay, so suppose that there is one beam of light. Okay? Now this beam of light will have different radiations, different wavelength radiations. Okay? जैसे आप मान लीजिए कि आपका लाइट आता है सनलाइट. सनलाइट जो आता है उसमें क्या है कि डिफरेंट डिफरेंट कलर होते हैं. कलर जैसे सनलाइट में डिफरेंट कलर होते हैं. सो डिफरेंट कलर मतलब क्या, दे आर हैविंग डिफरेंट वेवलेंथ. सो sunlight is a band, it is a band of different wavelength, different light of different wavelength, it is a packed band of different wavelength. Okay, so if you pass this band of sunlight through a prism, through a prism, a prism, this is known as a prism. If you pass a light through a prism, okay, so this a band of light having different wavelength. Okay, ये जो लाइट का बैंड होता है इसमें डिफरेंट वेवलेंथ होता है, वेवलेंथ ऑफ लाइट होता है. लाइट और व्हाइट लाइट इज नोन एज अ पॉलीक्रोमेटिक लाइट, इट इज नोन एज अ पॉलीक्रोमेटिक लाइट. ये जो है उसको क्या बोलेंगे, पॉलीक्रोमेटिक लाइट. पॉली मतलब क्या है, बहुत सारा. पॉली मतलब बहुत सारा. क्रोमेटिक मतलब क्या है, क्रोमेटिक मतलब क्रोमा मतलब कलर. तो पॉलीक्रोमेटिक मतलब क्या है कि ये जो लाइट है इसमें बहुत सारे कलर्स है. सो इट इज नोन एज अ पॉलीक्रोमेटिक लाइट, इट इज नोन एज अ पॉलीक्रोमेटिक लाइट. So it will have different colors, or colors means colors for particular wavelength. So it will have different wavelength rays. It is a band of that. So it is a polychromatic light. Okay. So that polychromatic light when passed into a prism, so you will get a dispersion. This light will be dispersed in a different part. ये separation हो जाएगा उसका. So you will get a red light, orange light, yellow light, green light, blue, indigo, and violet. So these are nothing but the 7 colors of your rainbow. So your light is dispersed in the prism and will be converted into a monochromatic. तो इसको जो यहाँ से जो light आ रहा है, this light, okay, this light is a polychromatic. Okay, and now वो separation हो गया उसका particular wavelength की. रेड कलर का एक पर्टिकुलर वेवलेंथ रहेगा रेड लाइट, ऑरेंज लाइट का एक पर्टिकुलर वेवलेंथ, येलो लाइट का एक पर्टिकुलर वेवलेंथ, ग्रीन लाइट का एक पर्टिकुलर वेवलेंथ. ठीक है. सो पर्टिकुलर वेवलेंथ मतलब ये क्या है, मोनो. मोनो मतलब क्या, एक. रेड का सिर्फ एक ही वेवलेंथ रहेगा. So it is known as a monochromatic light. Okay, monochromatic light. So mono. So polychromatic and monochromatic. Is that understood? Because you have to understand this. What is polychromatic and what is monochromatic? So your normal light is a band of different colors. Okay, that's why it is known as a polychromatic light. And when you pass a polychromatic light through a prism or grating, so it is dispersed into a monochromatic light. तो पॉलीक्रोमेटिक लाइट जब पास करेंगे प्रिज्म से तो आपको डिस्पर्शन मिलेगा, एंड दैट लाइट विल बी कन्वर्टेड टू मोनोक्रोमेटिक. तो हर एक अलग अलग कलर रहेगा. सो दीज आर द 7 कलर नोन एज अ रेनबो कलर. सो नॉर्मली होता है ना, व्हेन देयर इज अ साइमल्टेनियस रेनिंग एंड व्हेन देयर इज अ साइमल्टेनियस सनलाइट in the sky, you will see this rainbow. Okay, so because of that the dispersion produced by the that light, water and light होता है simultaneously. उसमें क्या है, it will act as like a prism. और उसमें से अगर sunlight आता है, so that sunlight will be dispersed into rainbow. At that time that act as a prism. So polychromatic light will be converted to monochromatic light by the prism. Now in the spectroscopy you measure different types of physical properties, different type of physical properties that are used for the analysis. So for example, some compound will absorb the radiation. Okay, so absorption of radiation is measured in the these kind of spectroscopy. Like absorption of radiation is measured in the X-ray spectroscopy, UV visible spectroscopy, IR spectroscopy, then colorimetry, atomic absorption spectroscopy, nuclear magnetic resonance, electron spin resonance spectroscopy. ठीक है, UV, IR, visible, X-ray, colorimetry, atomic absorption, NMR, nuclear magnetic resonance, electron spin resonance. So these are the these are the techniques of spectroscopy where you measure absorption of radiation. Absorption measure करेंगे. Now there are certain techniques which measures the emission of radiation. So जो emitted radiation है, emitted मतलब जो वहाँ से emit किया है, so उसको, So emission spectroscopy, for example, X-ray emission is there. UV emission means fluorescence. Visible emission means also fluorescence. So flame, okay, X-ray emission, UV emission or visual emission. Then flame photometry, fluorescence, X-ray, UV, visible. उसमें आता है. And then radiochemical methods. So these methods measure the emission of light. तो कौन से मेथड है? एब्सॉर्प्शन मेजर करेंगे ये वाले, इमिशन मेजर करेंगे ये वाले. नाउ स्कैटरिंग, scattering of radiation. Some of the compound will, when there is a falling of light on compound, these compounds either they may absorb, मैंने तो पहले बोला है. So when there are different possibility, when a light fall on a compound may absorb it completely, or a part of it will be absorbed, or it will transmit the light, okay, or it will scatter the light, it will reflect the light, it will refract the light, okay. So depending on that type of physical property measured, so if there is absorption of light, then absorption spectroscopy. If there is emission of light, emission spectroscopy. If there is scattering of light, scattering. So scattering of light means, okay, scattering of light is measured in the Raman spectroscopy, nephelometry and turbidometry. Question इसके ऊपर आ चुका है. Scattering of light or scattering of radiation is the phenomenon involved in the following type of spectroscopic technique. So nephelometry में और turbidometry में आता है. Nephelometry more specifically. So question इसके ऊपर GPAT में आ चुका है. Scattering of light is involved in the nephelometry. Now refraction of radiation is involved in the refractometry and interferometry. Refractometry, interferometry. Diffraction of radiation is involved in the X-ray, electron diffraction methods. These kind of spectroscopy. Then rotation of radiation is involved in the polarimetry, optical rotary dispersion and circular dichromism. Rotation of radiation. So rotate a compound, if compound is optically active, that means it will rotate the plane polarized light either clockwise or anti-clockwise. So for that, rotation is measured in the particular type of analysis. So in case of polarimetry, rotation is measured. Optical rotary dispersion also deals with the measurement of rotation of radiation. Circular dichronism is also measure the rotation of radiation. Now electrical potential is measured. Electrical potential is a property that is measured in the, so electrical potential is measured in the potentiometry or chronopotentiometry. Electrical resistance is measured in the conductometry. Conductometry में क्या है? Electrical conductance measure करेंगे. इलेक्ट्रिकल करंट का आप मेजर करेंगे पोलरोग्राफी एम्पिरोमेट्रिक प्रैक्टिशंस. क्वांटिटी ऑफ इलेक्ट्रिसिटी इज मेजर्ड इन द coulometry and mass to charge ratio is measured in the mass spectroscopy. Thermal properties of compound is measured in the thermal conductivity analysis or enthalpy methods. These are the different properties of compound that is measured. कौन सा प्रॉपर्टी किस में मेजर करेंगे, कौन सा प्रॉपर्टी किस में मेजर करेंगे. तो एब्सॉर्प्शन का मेजर करेंगे, इमिशन का मेजर करेंगे, डिफ्रैक्शन, रिफ्रैक्शन, ठीक है, रोटेशन ऑफ रेडिएशन, इलेक्ट्रिकल पोटेंशियल, कंडक्टेंस, ठीक है, करंट का मेजर करेंगे, ठीक है, इलेक्ट्रिसिटी का मेजर करेंगे, मास टू चार्ज रेशियो किस में मेजर करेंगे, थर्मल प्रॉपर्टीज का आप मेजर करेंगे. सो डिफरेंट फिजिकल प्रॉपर्टीज मेजर्ड एंड रिस्पेक्टिव इंस्ट्रूमेंटल मेथड ऑफ, इट इज जस्ट द इंट्रोडक्शन पार्ट. ये भी आपको मालूम होना चाहिए, क्वेश्चन उसके ऊपर पे आता है. अगेन नाउ स्पेक्ट्रोस्कोपी इज नथिंग बट द measurement and interpretation of electrochemical radiation absorbed or emitted by molecule when it moves from one energy state to another energy state, when it moves from ground state to excited state. Types of spectroscopy कितना रहेगा? Types of spectroscopy, it depends. The types of spectroscopies, they are classified depending upon the different properties. Okay, so if the radiation interacts with the atomic level, if पर्टिकुलर रेडिएशन और जो लाइट आपका जो रेडिएशन यूज कर रहे हो वो अगर एटम से इंटरेक्ट करता है, इफ दैट रेडिएशन इंटरेक्ट with the atoms of molecule or that interact with the atomic level of the molecule, then it is known as atomic spectroscopy. So interaction of electromagnetic radiation with the atoms which are most commonly in their lower energy state known as a ground state. So interaction of electromagnetic radiation with the molecule at an atomic level known as atomic spectroscopy. Second one is a molecular spectroscopy. So interaction of electromagnetic radiation with the molecular level. So interaction of electromagnetic radiation with the molecules which result in the transition between rotational, vibrational and vibrational energy levels. Okay, rotational, vibrational, electronic energy levels. So known as a molecular spectroscopy. जैसे atomic spectroscopy मतलब atomic absorption spectroscopy, AAS. Molecular spectroscopy means what? So it is an example is nothing but the IR spectroscopy and UV spectroscopy. So UV में क्या होता है? So there is a change in the electronic transitions. So there is a electronic transition in the IR. And what is the electronic transition in the UV? Now in case of IR, rotational and vibrational changes are there. That is IR. So IR and UV are type of molecular spectroscopy. Atomic spectroscopy क्या है? Atomic spectroscopy मतलब क्या है? Whatever radiation is there, that radiation if interact with the atomic level, कि एटम के साथ में इंटरेक्ट करता है तो उसको बोलेंगे एटॉमिक स्पेक्ट्रोस्कोपी. अगर वो मोलिकुलर लेवल पे इंटरेक्ट करता है तो उसको बोलेंगे मोलिकुलर स्पेक्ट्रोस्कोपी. नाउ अगेन रोटेशनल स्पेक्ट्रा. ओके, मोलिकुलर स्पेक्ट्रोस्कोपी में डिफरेंट डिफरेंट टाइप आता है आपका. For example, first one is the rotational spectra or microwave. So rotation of the molecule or rotation of the structure is involved in the microwave region. The spectra is due to transition between rotational energy levels of gaseous molecule on the absorption of radiation falling in the region of microwave. अगर microwave radiations अगर कोई compound पे गिरते हैं तो okay, for example gas molecule, so there is a change in the rotational energy. So there is a transition in the rotational energy. So that's why it is rotational spectra or microwave. So microwave spectra is shown by the molecules which has a permanent dipole moment. जिसमें permanent dipole moment रहेगा उसको उस ऐसे molecule ये आपका rotational spectra दिखाएंगे. जैसे hydrochloric acid HCl, okay, then carbon monoxide, then water, then nitric oxide. Okay, so HCl, CO, H2O, and so these molecules they have permanent dipole moment. Okay, and that's why their rotation can be changed upon by giving up energy of particular strength, and that energy lies in the microwave radiations. So known as the rotational spectroscopy. Vibrational and rotational infrared spectrum. So here infrared radiations spectrum arises due to a transition induced between rotation vibrational energy level of the molecule upon the absorption of radiation, that is infrared radiation. The spectrum is shown by the molecule when there is a vibrational motion is accompanied by change in the dipole moment of the vibrational energy level. Change हो जाएगा, transition of vibrational energy level. Okay, vibrational energy level transition and those molecule which are having dipole moment. इसमें डाइपोल मोमेंट है उसमें वाइब्रेशनल एनर्जी का लेवल चेंज करेंगे. ऐसे रेडिएशन का एनर्जी कौन से ऐसे रेडिएशन कौन से infrared. Okay, and the measurement of that transition is there in a infrared spectroscopy. So spectrum arises due to transition induced between vibrational energy level of the molecule on absorption of radiation belonging to infrared region. The spectra is shown by molecule when a vibrational motion is accompanied by change in the dipole moment. Raman spectra किसको बोलते हैं? Raman spectra किसको है? So it is related with the vibrational and rotational transition again in the molecule at a different one. Okay? लेकिन उसमें थोड़ा different है. Okay? Where we measure a scattering of incident beam, not absorption. So in the पहले होता था आपका माइक्रोवेव स्पेक्ट्रोस्कोपी, रोटेशनल स्पेक्ट्रोस्कोपी, उसमें भी एब्सॉर्प्शन ऑफ माइक्रोवेव रेडिएशन इज मेजर्ड. जो इंफ्रारेड है वाइब्रेशनल रोटेशनल, तो उसमें भी आप इंफ्रारेड का एब्सॉर्प्शन मेजर करते हो. बट इन केस ऑफ रमन स्पेक्ट्रोस्कोपी इट आल्सो डील्स विद द vibrational and rotational energy of the molecule. So it also there is also transition between vibrational and energy, the vibrational and rotational energy in the Raman spectra also. But here we don't measure a absorption of radiation. Here we measure a scattering of radiation. Okay. So intense beam of monochromatic visible light is passed through a sample and scattering is measured at a right angle to the incident beam. That is a Raman spectroscopy. Okay. जस्ट इंट्रोडक्शन. रमन स्पेक्ट्रोस्कोपी के ऊपर पूरा चैप्टर आता है. ठीक है, यूवी के ऊपर पूरा चैप्टर आता है, आईआर के ऊपर पूरा चैप्टर आता है. मोस्ट ऑफ द स्कैटर्ड लाइट इन द रमन विल हैव सेम फ्रीक्वेंसी. मोस्ट ऑफ द स्कैटर्ड लाइट फ्रॉम द इंसिडेंट लाइट विल हैव सेम फ्रीक्वेंसी known as a Rayleigh scattering. However, small amount of light which has a difference between incidence and scattered frequency is known as a Raman scattering. And this Raman scattering was found by Indian साइंटिस्ट नोन एज सीवी रमन. इंडियन साइंटिस्ट थे सीवी रमन, उन्होंने ये रमन स्कैटरिंग और रमन स्पेक्ट्रा फाउंड किया. दैट लाइज इन रीजन बिटवीन 12,500 to 25,000 सेंटीमीटर इनवर्स. ये एक्चुअली इसके ऊपर कभी क्वेश्चन ज्यादा आता नहीं है. देन इलेक्ट्रॉनिक स्पेक्ट्रा. इलेक्ट्रॉनिक स्पेक्ट्रा इज ड्यू टू द ट्रांजिशन ऑफ मॉलिक्यूल upon absorption of radiation of UV region, UV लाइट को absorb करके जो इलेक्ट्रॉनिक ट्रांजिशन होता है, इलेक्ट्रॉन्स में, so that is known as a electron spectra or photoelectron spectra. So electronic spectra, that is a changes in the electrons of the molecule. Okay, so due to transition in the molecule by absorption of UV rays, UV spectroscopy. Then nuclear magnetic resonance types of scopy चल रहा है. Next one is a nuclear magnetic resonance or nuclear quadrupole resonance, NQR, NMR or NQR. Now these spectra arises due to the transition induced between nuclear spin energy level of the molecule. तो molecule में क्या है कि molecule will act as a magnet, so it will have a dipole. Okay, so if you place that atom in an external magnetic field, their spin state can be changed, okay, by absorption of radio frequency. ठीक है, अगर आपको कोई molecule है जिसका spin quantum number half integral है 1/2 3/4 ऐसा, so if that molecule is placed in the external magnetic field, it will either align or it will oppose. It will either stand with the magnetic field or it will oppose the magnetic field. ये दो possibility. Or in that condition, if you pass a radio frequency wave in that atom, so that atom will absorb the radio frequency wave and will change its spin. जो align था वो oppose हो जाएगा, जो oppose है वो align हो जाएगा. So change in the spin state. Okay? So these spectra are just due to the transition induced between the nuclear spin level of the molecule in applied magnetic field. So again NQR, that is a nuclear quadrupole resonance, arises due to transition between molecular spin level of the molecule arising from interaction of symmetrical charge distribution in the nuclear with the electric field gradient. So NQR is not important for you. Next one is electron spin resonance. Electron spin resonance known as ESR or electroparamagnetic resonance. EPR. Electron spin resonance or electroparamagnetic resonance. So spectra of transition induced between electrons spin energy level of a molecule in applied magnetic field. The spectra is exhibited by the system which contain odd, that is unpaired electrons, free radicals and transition metals. तो ये इलेक्ट्रॉन स्पिन रेजोनेंस जिसमें ऑड इलेक्ट्रॉन्स होंगे, अनपेयर्ड इलेक्ट्रॉन्स होंगे, free radicals, transition metal जो है, they will show this electron spin resonance. So these are the types of spectroscopy. Okay, then again Mossberg spectra. Okay, Mossberg spectra is known as a, also called as a nuclear gamma resonance fluorescence spectra, NRF, nuclear gamma resonance fluorescence, NRF, nuclear gamma resonance fluorescence spectra. Mossberg, याद रखो, it is a type of nuclear magnetic resonance result from the low energy photons. जो normally NMR में है, that is a high energy photons, हाई एनर्जी रेडियो फ्रिक्वेंसी होता है, और मॉसोबर स्पेक्ट्रम में लो एनर्जी रेडियो फ्रिक्वेंसी वेव्स यूज करते हैं. दैट्स डिफरेंस वही है. सो अराउंड 60 मेगाहर्ट्ज. नाउ मॉसोबर स्पेक्ट्रा इज ड्यू टू द एब्सॉर्प्शन ऑफ हाई, ओके, मॉसोबर स्पेक्ट्रा इज ड्यू टू द एब्सॉर्प्शन ऑफ हाई एनर्जी gamma photon of the frequency around 330. What is light? Light is nothing but the electromagnetic energy. It is a radiant energy emitted by fluctuation of electrical charge and magnetic field. Like light, there are various forms of electromagnetic radiation. Light क्या है? What is the radiation? What is meant by radiation? So a particular radiation is nothing but it is a electromagnetic energy emitted. Okay, it is a electromagnetic energy, radiant energy emitted by fluctuation of electrical charge and magnetic field. Like light, there are, okay, like light, जो light है, what is light? Light is nothing but the kind of electromagnetic energy. So it is a radiant energy emitted by fluctuation of your electric charge and magnetic field. And likewise, जैसे light भी होता है आपका electromagnetic energy, उसी टाइप के दूसरे magnetic energy भी होते हैं. जैसे like there are various forms of electromagnetic radiation like ultraviolet, infrared, X-ray, radio waves. Okay, they are produced by oscillation of electric charge and magnetic field residing on an atom. They are mutually perpendicular to each other. They are characterized by wavelength, frequency, and wave number. Energy carried is directly proportional to the frequency, inversely proportional to the wavelength. Energy carried by a particular light एनर्जी कैरिड बाय पर्टिकुलर लाइट इज डायरेक्टली प्रोपोर्शनल टू द फ्रीक्वेंसी। जितना ज़्यादा फ्रीक्वेंसी रहेगा उतना ज़्यादा उसका एनर्जी रहेगा, लेकिन जितना ज़्यादा वेवलेंथ रहेगा उस उतना ही कम उसका एनर्जी रहेगा। एनर्जी ऑफ इलेक्ट्रोमैग्नेटिक रेडिएशन इज डायरेक्टली प्रोपोर्शनल टू द फ्रीक्वेंसी एंड इनवर्सली प्रोपोर्शनल टू द वेवलेंथ। तो वेवलेंथ जिसका ज़्यादा है उसका एनर्जी कम रहेगा, जिसका वेवलेंथ कम है उसका एनर्जी ज़्यादा रहेगा। इमिशन और एब्सॉर्प्शन ऑफ रेडिएशन इज quantized, मतलब quantified। Absorption or emission of radiation is quantified on the basis of radiation known as a photon। तो photon क्या है, उसका मेजर है photon। Now if light is passed through a prism, we have seen that, so it is dispersed into different wavelength known as a dispersion। If a particular molecule will absorb a wavelength of light, it is due to changes in the either electronic or vibrational or rotational energy level of the molecule permissible। The wavelength absorbed are measured with the help of particular instrument known as a spectro। Absorption bands is a characteristic of particular compound। Particular compound UV में एक्टिव है, पर्टिकुलर कंपाउंड IR में एक्टिव है, IR में कितना का किस फ्रीक्वेंसी पे एब्सॉर्ब करता है, इट इज अ कैरेक्टरिस्टिक ऑफ पर्टिकुलर। यू कैन सी दिस इज नथिंग बट द वेवलेंथ। ठीक है, वेवलेंथ भी ट्रैवल करेंगे, ऐसा ऐसा भी होता है। फॉर एग्जांपल दिस इज इलेक्ट्रॉनिक पार्ट एंड दिस इज मैग्नेटिक पार्ट। तो ये इलेक्ट्रॉनिक कंपोनेंट है, ये मैग्नेटिक कंपोनेंट है, दे आर पैरेलल टू ईच अदर। So distance between two successive crisps or distance between two successive top is known as a wavelength। So wavelength is distance between two adjacent crisps or top of a particular wave denoted by lambda। Wavelength कैसे denote करते हैं, lambda। Now also expressed as a angstrom unit or micron। तो lambda भी बोलते हैं उसको, या फिर आप angstrom में भी denote कर सकते हो, मिली माइक्रोन में माइक्रोमीटर। One angstrom is 10 raised to minus 8 centimeter or 10 raised to minus 10 meter। ठीक है, 1 angstrom is 10 to minus 8 centimeter or minus 10 meter। 1 micrometer is 10 raised to minus 6 centimeter or minus 10 raised to minus 5 meter। विजिबल लाइट रेंज कितना होता है, विजिबल लाइट कितना रेंज होता है, 3800 टू 7600। मतलब आप यहाँ पे एक रफली 400 इसको बोलेंगे, 400 इसको बोलेंगे 800। विजिबल रेंज ऑफ लाइट इज नथिंग बट द 400 टू 800 नैनोमीटर। नाउ वेव नंबर क्या है, नंबर ऑफ वेव्स पर सेंटीमीटर विच इज रेसिप्रोकल ऑफ योर वेवलेंथ and expressed as a per centimeter or means inverse centimeter inverse per centimeter means inverse centimeter। Total number of waves that can pass through a space of 1 centimeter। Okay, that is wave number। Wave number is the reciprocal of your wavelength। ठीक है, यहाँ पे देखो फॉर्मूला भी है उसका, wave number is equal to reciprocal of wavelength। Okay, if wavelength of radiation is 2.5 micron, corresponding wave number will be calculated in the by the formula। For example, ठीक है, लैम्डा क्या है 2.5। ठीक है, मतलब वेवलेंथ है 2.5 माइक्रोन इज इक्वल टू 2.4 इंटू 10 रेज़ टू माइनस 4 सेंटीमीटर इज इक्वल टू, ठीक है, फॉर्मूला क्या है 1 अपन वेवलेंथ। तो 1 अपन वेवलेंथ 1 बाय 2.4 इंटू 10 रेज़ टू माइनस 4 सेंटीमीटर, सो इट इज नथिंग बट द 4000। कैलकुलेट करके ये कितना आएगा 4000। सो यू कैन कैलकुलेट द वेव नंबर। अगर आपको वेवलेंथ दिया है तो सबसे पहले वेव नंबर का फॉर्मूला याद रखना चाहिए, 1 अपॉन लैम्बडा सेंटीमीटर। तो सेंटीमीटर में है क्या है, सेंटीमीटर में वेवलेंथ चाहिए आपको। यहाँ पे दिया है कहाँ, यहाँ पे दिया है माइक्रोन में, यहाँ पे वेवलेंथ क्या दिया है माइक्रोन में। तो फर्स्ट यू हैव टू कन्वर्ट दैट माइक्रोन इनटू सेंटीमीटर। सेंटीमीटर में कन्वर्ट करो, जैसे यहाँ पे 1 एंड आफ्टर दैट 1 अपॉन दिस 2.4 into 10 raised to minus 4 centimeter will give you 4000 centimeter inverse। That is a wave number। wave number को कैसे कैलकुलेट करेंगे समझ में आएगा। How to calculate the wave number if they have given the wavelength? You got it or not? Frequency क्या है, number of waves। Frequency क्या है, number of waves that can pass through one point in a 1 second। Frequency is inversely proportional to the wavelength and it is expressed as cycle per minute or hertz। We have seen that। Greater the wavelength, smaller will be the frequency। Greater the wavelength, smaller will be the frequency। ये याद रखो, जिसका ज़्यादा वेवलेंथ है उसका फ्रीक्वेंसी कम रहेगा, जिसका फ्रीक्वेंसी ज़्यादा है उसका वेवलेंथ कम रहेगा, जिसका फ्रीक्वेंसी ज़्यादा है उसका एनर्जी ज़्यादा रहेगा, जिसका वेवलेंथ ज़्यादा है उसका एनर्जी कम रहेगा। तो फ्रीक्वेंसी इज इक्वल टू C divided by lambda। C is we have seen the energy of wave of a particular radiation is calculated by E is equal to HV। okay, is equal to H into C divided by lambda। we have seen this। Planck constant होता है आपका B is nothing but the frequency of radiation, and C is nothing but the velocity of electromagnetic radiation. Lambda is the wavelength in scientific. Types of spectroscopy based upon the level of study. पहला होता है atomic पहला होता है atomic spectroscopy. If electromagnetic radiations will interact with the molecule at atomic level, it is known as atomic spectroscopy. Example is nothing but the atomic absorption spectroscopy, flame photometry, flame photometry, atomic absorption or atomic emission. Both are studied. If radiation interact with the sample at a molecular level, then it is known as a molecular spectroscopy. So energy changes at a molecular level, like UV, IR, colorimetry, fluorimetry. यहाँ पे absorption भी हो सकता है, emission भी हो सकता है. Again, based upon the absorption and emission. So whether light is absorbed or emitted. So depending on that, spectroscopy is classified. So absorption spectroscopy. So absorption मतलब light का absorption होगा. So absorption of radiation is studied in case of UV, IR, NMR, and colorimetry. Then emission spectroscopy. So emission of light will be there, and that is studied. So in case of flame photometry and fluorimetry. Okay. Now next is based upon the level of electronic or magnetic, whatever radiation is there. So if that interact with the electrons of the molecule, then known as electronic spectroscopy. And if it interact with the magnetic energy of molecule, then known as magnetic spectroscopy. Electronic spectroscopy. You only use the electromagnetic radiation without magnetic field, without part of magnetic field. Implant नहीं है, ये part है. Only use electromagnetic radiation without its magnetic part. Example is UV, colorimetry, fluorimetry. Then again magnetic spectroscopy. Okay, so electromagnetic radiation without electronic part. Example is nuclear magnetic resonance, electron spin resonance. Total energy of molecule कैसा होता है? Total energy of molecule is equal to rotational energy plus vibrational energy plus इलेक्ट्रॉनिक एनर्जी. तो उसका एक प्रोपोर्शन भी होता है, ये प्रोपोर्शन भी यहाँ पे दिया है. रोटेशनल एनर्जी 1 as to vibrational energy 100 as to electronic energy 10,000. When any electromagnetic radiation is passed on the molecule, energy changes takes place in a molecule at a molecular level or atomic level, which is measured in the spectroscopy. ये सब इंट्रोडक्शन